All right, so today's video is all about sketching a curve. This curve that we're talking about is any of those polynomials besides your x squareds and even your lines. I want to say that when we're looking at these, this obviously could apply to your x squareds, but it's not as necessary. We can be more precise because we can find the turning points, or we can find those intercepts and establish what they look like. When we're talking about a polynomial that's something like x cubed or x to the fourth or x to the fifth, what we're looking at here is we're just trying to get an idea. When you get to calculus, you'll get more details even still. But for right now, all we're looking at is getting just some idea of what this graph looks like. As with any graph I'm going to teach you this year, we will always want the x and the y-intercepts. Let me say that again. Every graph that I will do in this class will require the x and the y-intercepts. So it seems only poignant that I would use for the first two steps your x and your y-intercepts. In order to determine the x-intercept, anytime, no matter what the graph, it's always when y equals 0. And so no different. Here, I'm going to do this example along with these steps so you can see what I'm talking about. What we're going to do is we're going to, excuse me, I shouldn't put that there. I'm going to put 0 in for y, and then I'm going to solve. So what I have here, and since this is already factored for me, it's like almost all the work is done already, believe it or not. If it's not factored like you see here, and I'm going to try and do another example for you in this video, you'll see that then we have to factor at this point, to which if you don't know how to do that, you'll need to refer back to those former videos that teach you how to factor polynomials such as this. All right, but here we go. We have this already factored. Beautiful. So that means we can easily see the roots or the solutions, the x-intercepts here. We've got x equals 0. That's the obvious. X equals -1. Now this one, I want you to think, is really just saying x minus 2 squared, which just means 2 times, right? So really that's saying like x equals 2 different times. It's really not necessary to write it down 2 times. So I'm just going to leave it at that. And so for our example, I have 0, -1, 2, and 4. All right. Now, my y-intercept is when x equals 0. In the past, that was pretty easy because all you would do is look at the end, look at that constant, and there it was. But you'll see, this case, it's not that way. So what I have to do instead is plug 0 every place I see an x, and then establish what that would actually equal. Now, when we look at this particular equation, we have 0 times, and who really cares about the rest of it? Because what do we know? 0 times anything is 0. Good. So the y-intercept is 0. Now, knowing all of that, that helps me actually set up for my graph. So what I'm going to do next is I'm going to draw my axes before I can begin the next step. I have x equals 0. That's one of my intercepts. I have x equals -1. So I'm going to label that with a point. I have 2. And I have 4. Now you'll notice I'm still labeling all of my x-intercepts. My y-intercept is 0, and so I have the x and the y at the same spot, so that also has been taken care of. Now, this next step in solving, okay, when we're doing this, is to determine the direction of the graph. Now you might think, how do I do that? Well, to determine the direction of the graph, what you're going to basically do is you are going to pick values on each side of your x-intercepts. And then what you basically are looking at is, look to see if it's positive or negative value. We don't even care what the actual quantity is. All we care about is if it's positive or negative. If it's positive, then the graph must go up. If it's negative, then the graph must go down. All right, well, it doesn't really make a lot of sense until we start doing it with this example. So what I'm going to do is I'm going to just erase this so I have a place to work. And I'm going to show you what I'm talking about. So here I've got my equation. Y equals x times x plus 1 times x minus 2 squared and x minus 4. So the first value that I'm going to choose is a number that is to the left of -1. So let's pick -2, something simple. Now what I mean by test, all I'm saying is every place you see an X, I want you to put -2. And think to yourself, does that make it positive or negative? So if I put -2 in for X, do you follow that that's a negative number? -2 plus 1 would also be a negative value. -2 minus 2, when I square it, will become positive. In fact, every term when I square it will become positive. And then -2 minus 4 is negative. Now remember, these are all multiplying. And they will, when we factor, we'll get all the factors. What multiplies to give you this number? So now what we're asking ourselves is, two negatives make a positive, and then you have a negative here. So overall, this graph is going to be negative or go down to the left. Now, if you think about the next value that we're going to look at, that would be -1/2, just to pick a value between -1 and 0. Okay, you might be a little intimidated by the fact that it's a fraction, but remember, all I care about is if it's positive or negative. So when I put -1/2 in for X, that gives me a negative number. -1/2 plus 1. Well, -1/2 plus 1 is just a positive number. We really don't even care what it is, even though we probably know that it's positive 1/2. How about -1/2 minus 2? Well, that would be negative, but you square it and it becomes positive. And -1/2 minus 4 is still negative. Again, two negatives make a positive. So two negatives make a positive. So overall, this is positive plus times positive times positive times positive. Overall, that part of the graph is positive. So all that means is I'm going to do a bump connecting these 2 points up. Now pick a number between 0 and 2. Not sure if you could hear that, but that was Mrs. Turner. Wasn't that great? All right. Anyway, so back to our regularly scheduled program here. We have between 0 and 2. We want to pick a number that's between 0 and 2. And of course, I think the easiest one, of course, would be 1. Plug 1 in for X. That's a positive number. 1 plus 1 is positive. 1 minus 2 is negative. But then we square it, it becomes positive. 1 minus 4 is negative. Overall, when you multiply this out, do you see how there's an odd amount of negatives? That makes this negative, which means that that was a negative value. We don't even care what that number is. We just know it's negative. So that means between 0 and 2, we're going to connect it below. All right, now we're going to pick 3 because that's the number between 2 and 4. Again, positive or negative, that's all we care about. 3 is positive. 3 plus 1 is positive. 3 minus 2 squared, positive. 3 minus 4, negative. What does that mean? Overall, it's negative also. So that means between 2 and 4 also goes below. Now, I don't really care how low those dips are. That's the part in calculus that you would find out. What goes on between those numbers, all I care about is that you loop above or below. That's all I'm looking for. Now, we're not quite finished yet because we got to figure out to the right of 4. So pick any number bigger than 4. It could be 10. It could be 100. In fact, I'll do 10 just to mess with you a little bit, but you probably chose 5. 10 in for X would be positive. 10 plus 1 is positive. 10 minus 2 squared, positive. 10 minus 4, positive. Overall, positive. That means this part of the graph goes up. And so there you have the very first example of seeing how we just use the intercepts and it just tells me up or down. That's all I'm looking for. Okay, so let's do another example here. Move this guy out of there. Bring this one in. Okay, y equals x to the 4th minus 13x squared plus 36. Well, I hope that it's easy enough to see what the y-intercept is. Since it's not factored for me, I can see that the y is 36. Good enough. The x-intercept is the one where y equals 0. And so guess what we're going to have to do to this? You betcha. We're going to have to factor. And so I get x squared and x squared. And then what are those two numbers? Great. And that factors down even more. Please continue to factor completely for that. Okay, so now we can quickly see our x-intercepts are -3, +3, -2, and +2. Does everybody follow that? Hope so. Okay, let's set up our graph. Now, we've got 1, 2, 3, and 1, 2, 3. So I've got at -2, -3, +2, and +3. Now, it would have been helpful, actually, if I left the factored form up there for you. We also have our y-intercept of 36. I'll call that 36. So let me just point out to you that in doing this graph, we already know that between -2 and +2, the graph must go up because it's got to hit that 36. So as nice as that's, and again, I don't really care how, whether it does some bumpy looking thing. In fact, I could draw some crazy thing as long as it hits that 36. Okay? So now we have to evaluate between all of these intercepts. So let's go ahead and do that. Again, it would have been helpful had I left that factored form, so I'm just going to write that down. Okay, so there we go. So now I'm going to test some roots. I'm going to start with -4, only because it's to the left of -3. So when I plug -4 in here, -4 plus 3, is that positive or negative? How about -4 minus 3? -4 plus 2, -4 minus 2. Again, we're multiplying, so 2 negatives make a positive, 2 negatives make a positive. Overall, this part is positive, so that part goes up. Now I'm going to pick a number between -3 and -2. You could say -2.5, or rather, -5/2. When I plug that in, plus 3, that would be positive. The next one, negative. The next one, negative. The next one, negative. So again, 2 negatives make a positive. So overall, though, we still have a negative left over. So that means between -3 and -2, it goes down. Okay, now between 2 and 3, again, positive 2.5 or positive 5/2. Same idea. Add it to 3, positive. Subtract 3, negative. Add it to 2, positive. Subtract 2, still positive. Overall, though, when we multiply, it's negative, so between 2 and 3, it also dips below. Now pick a number greater than 3. Again, it can be any number bigger than 3. I'm just going to choose 4. 4 plus 3 is positive. 4 minus 3 is positive. 4 plus 2 is positive. 4 minus 2 is positive. Overall, positive. So it goes up. So your graph, in essence, looks like that. And there you have it. And that's how you sketch a graph. In class, we'll be working strictly on this and working on especially testing in between those points, because I understand that'll be quite the challenge. All right, I'll see you tomorrow.